Hi everyone. On this video, I plan on describing what Perlin noise is, how we use that to generate noise bathymetry files, and why we do it. So to begin with, Perlin noise, it's a very soft form of noise. It's often used in CGI effects. For instance, when someone's trying to create fog, they would want to use Perlin noise. And it was generated really for that effect, to prevent fog and other CGI effects from looking very computerized, very fake. So as you can see with this image, there's some few hints of black and white, but for the most part, it's very smooth, very transitional. You don't have many spikes or edges and stuff. Here's another smaller picture of it. It's just very smooth data. So we use that when we are trying to map the ocean floor by multiplying, the Perlin noise that we generate with our bathymetry files, and that creates kind of smooth bumps and concave edges and stuff on the bathymetry file, which we then simulate sonar data off of. So how we actually do that, if you go to the GitHub, to bathymetry, to the folder AGC26, to the folder AT, which stands for Acoustic Toolbox, you can then find this file perlin2d.m. And this is the function generate Perlin noise. It was created by a guy named Steven Cholowiak, and the URL to find his work is right here, and it was modified by me. So what it does is it takes a given array of size m rows by n columns, multiplies that by randomly generated Perlin noise, and is finally centered around 0.5. And that's important because we really don't want negative depths, as this will be applied across the bathymetry file, which is an array of various depth files. So I've said this word a few times, bathymetry file.bty. What on earth is this? So an example, also in the same location, is the Weymouth3D.bty file. What's nice about the Acoustic Toolbox is it has a bunch of documentation under the doc file that explains what these files are. If I were to pull up the ATI_BTY_file.htm, I get this HTML version of the documentation describing what bathymetry file is. And bellhop is specifically what uses these files. So pulling up the example, it is a .r, meaning these values are the range of our data. It's 38 by 96, meaning 38 columns by 96 rows. And here is the actual depth value. And this is where we actually visualize our bathymetry file. If we were to put this in a visualizer, we actually see the simulated map of the ocean floor. Anyways, it's this data that we apply the Perlin noise to. As you can see right here, 0.1, 0.1, 0.1, it's very smooth. We want this to be a little more jagged. So when we apply bellhop 3D to it, we get simulated sonar data off of more rough patches, which is slightly more realistic to the ocean floor, which really is not as smooth as we'd hope. So back to Perlin 2D, this generates an array called S. If you go to the file generate_noisy_btys.m, this is how we actually apply the Perlin noise to it. This is a specific function to generate Perlin noise onto a bathymetry file. The inputs are S, Perlin noise, bathy file, which is the bathymetry file. If we're dealing with simulated data, it's the simulated bathymetry file that we want to noisify. And an M, number of rows and columns. And finally, bathy file edit, or the name of the new bathymetry file. And as this is put in a larger pipeline function to generate as many noisy files as we want, the bathy file edit is just the way we specify what file, what's the file name for this specific iteration of Perlin noise applied to the bathymetry file, as every Perlin noise is different due to this random number generator function right here in the Perlin noise generator. So how this works is we open up this bathymetry file that we're trying to noisify. we pull the header from it, we pull the values from it. We then, with this double nested while loop, we apply Perlin noise to our specific value. It reads the M and N values from the Weymouth 3D in this situation, or whatever the bathymetry file. It pulls this number of rows versus number of columns, and applies noise to it. We then save that on the file name bathyfile_edit, which is unique to this specific noisified bathymetry file, and we output that. So anyways, this is how we create noisy bathymetry files. In future in future videos, I will explain how we actually use this, how we make sound files, how we make pings off of it, how we use this to train neural network. I hope you liked the video. Please like and subscribe to Duke at X Prize. I'm a sucker for that kind of validation, and I hope you watch the future videos. Thank you.